What is sensitivity and specificity? These metrics are oftentimes used in diagnostic applications, for instance, to measure the effectiveness of a diagnostic. But what exactly do they measure? Let's start off with their formulas. So this visual shows positive cases in the green rectangle and negative cases as the outer red rectangle. Sensitivity is the number of correctly detected positive cases out of all positive cases. It basically answers how well our assay can cover this green rectangle. Specificity is the number of correctly detected negative cases out of all negative cases. It answers how well does our test or assay avoid false positives, or basically avoids the outer red rectangle. These values, in many cases, negatively correlate with each other, meaning that, for example, as you increase sensitivity or as you loosen what is considered a positive result, this can oftentimes lead to increased false positives or decreased specificity. And as you increase specificity or make the assay more specific to guarantee fewer false positives, usually the number of true positives are constricted and sensitivity falters. The following animation shows this. Our assay is represented by the circle. One of the assay's parameters, literally its radius in this case, was being tweaked. In the end, with the largest radius, we see that what it detects, or basically its area, has very high sensitivity and covers the whole green rectangle, but has much lower specificity. It detects a lot of red bits. As the radius was decreased, its sensitivity was lower, because it simply could not cover the edges of the green rectangle. But its specificity was significantly better, as much less of the circle was comprised of red bits. Can we do better? Of course, we just need to develop a better assay with a more appropriate discriminative ability. We see that when we use a different assay, literally a rectangle-based one, using the correct size parameters, the new assay is able to have 100% sensitivity and 100% specificity because it can perfectly demarcate between positives and negatives. In the real world, the boundary between positives and negatives is never this clean and simple. So our assays don't have both 100% sensitivity and specificity. Still, scientists' jobs is to try to make the most discriminative assays we can, trying to cover the green region as best as we can while missing the red region to optimize sensitivity and specificity. Thank you.